discussed about working with the data types. We learned about how to deal with the undefined type. So what is undefined type and how do we deal with undefined types? We learned about that. And one more point we discussed is about here, how to deal with the undefined references. So that means what is not defined and what is undefined. Both points we learned. Next, after understanding about what is undefined type, and one additional point I discussed about is related to union of types. We discussed union of types. So how a data type can be defined, multiple types can be defined for a variable. So that point also we learned. Next, in non-primitive types, we have primitive types. These are all primitive types. In primitive types, we have one more important is a null type. We need to understand about what is a null type. How do we define the null type? So the primitive types, we have a number, we have a string, we have boolean and undefined, and the null types, null. Actually, what is null and when these null types are expected? Technically, and I'm writing console.log x is equal to plus x. So I'm printing the value of x. Actually, it returns x as undefined because what happens is compiler will verify that, compiler will check that there is no value defined into this variable. And if the value is not defined into variable, then it designates as undefined. And it shows that as undefined. We have to check the undefined. By using undefined value, you need to check the undefined. Already I showed you in last session. Here the point is, sometimes we are expecting value into this during the runtime. This is at compile time. That means during the compile time. During the compile time. So the value is expected and you are not passing value. Then obviously it will assign undefined to x. That's the reason it will print undefined. Sometimes we expect value dynamically at runtime. At runtime, we expect value into it. At runtime, when we are expecting value into it, that means during the runtime, when we are expecting value into it, and runtime, the value is not provided. Value is not provided into x. Runtime means, for example, here I am using prompt. So enter number. Actually, prompt, if you know JavaScript, prompt is a message box. Actually, it is an input box that pops up in the browser and asks you to input a value. When you input the value, that means the value inside this is expected at runtime. Value expected at the runtime. Generally, it is expected at the runtime. So when it is expected at the runtime, what happens here is this value is not provided at runtime. That means the value compiler will continue. Why? Because compiler thinks that, okay, the value will be provided at runtime. Then it will not put undefined into it. It will not put undefined into it. Now it will allocate memory for this X at runtime because it is attached with a prompt. And runtime, you are not passing value into it. Without passing value, you submitted. Then now this time, if runtime, you are not submitting a value, you are not providing a value, then it will return null. So if value is not provided at runtime, then it returns null. If value not provided at compile time, then it returns undefined. Actually, null is an exception. Null is an exception type which indicates that there is no value provided, which indicates that there is no value provided into reference. There is no value provided into reference. So no value provided into reference. So if value is not provided, that's the reason we call null exception came. Null exception came means we are expecting value, mandatory, and we are using it. And value, unfortunately, is not supplied to it. Then at runtime, it will not put undefined. At runtime, it will simply put as null. At runtime, it will simply put as null. That is what actually the null type. I will show you one example, but for this, we need to integrate with our browser. That means we have to integrate in HTML. Then only we can handle this. Let's see how we can integrate with HTML and how to handle this. Then we can understand this, what is actually happening. Observe here. For this, I will create an LET. So username is a string type. Into that username, we are expecting value from prompt. We are expecting value from prompt. In the prompt, we say enter name. Okay. Prompt is a JavaScript input box. Okay. And I am writing the condition. So here, we are expecting two values into this. We are expecting two values actually into this. One is the string. Another one, we are expecting pipe. We are expecting a null also. We are expecting a null. A string and a null is expected. That means we use the union of types. And here we will write a condition. If username is equal to, so null type is verified by using the keyword null. If username is null, then I will just put here document.write. Document.write, I will put here as document.write is a function which is used to print in HTML. Currently, I am not printing in console because prompt is related to HTML. We need to manage this in HTML. Then here I will define a statement, you cancelled. Else important, else if I'm writing another condition, if username is equal to empty and null both are different. Actually, empty will submit a blank, an empty space. That means it is occupying the memory. and the memory contains a blank. Usually blank is a space, an empty blank value. Blank is also a value. So null means not even also blank. That means if it is empty, then document dot write. I will put a message here. So here the message, we will say that name cannot be empty. Name cannot be empty. Else what should happen? Document dot write. I need to print the name, hello, and whatever the name user entered, username. These are the consequences we are expecting from the prompt. Actually, you can see. So what is the prompt and how the prompt actually works? That means, and I need to first transcompile this into JavaScript. I will transcompile this into JavaScript. str demo. Okay. So tsc str demo.ts. I'm transcompiling into JavaScript. Okay. Now, once it is converted into JavaScript, don't run it here because this program contains a lot of browser object related contents. If you run here, it will show errors. You have to integrate that JavaScript into HTML. So let's add one HTML page. So home.html. In that HTML page, we will link that string JavaScript file. So script source is equal to, it is a string demo.js. That's it. I will run this in the browser. So when we run this in the browser, it will prompt a message box, input box like this. You can see input box is having enter name and asking name. Actually, here 3 consequences are there. So that means 3 important points are there. What are those 3 consequences? I will show you. Actually, what happens in this now is technically, so there are 3 consequences like user can click OK. User can click OK. OK. So without value. Without value. That means without any value inside it. Then it will submit empty, which is referred with double quotes. That means without value, when you click OK, it will submit empty. It is going to submit empty. Okay. With value, I submit here. With value, I click OK. OK with value. That means it will get that value. So whatever the value entered. With or without value, I clicked cancel. With or without value, I clicked cancel. Cancel means actually this value is to be stored in a variable username. Username. It is a string type. It is a string type. And we are expecting value. You cancelled, that means there is no value passed into it. Then automatically at the runtime, if value is not provided into it, then our TypeScript will put a null into it. That means value is not supplied. You click cancel, then automatically it will submit null. It will submit null. You click OK without entering name, then it will submit empty. It will submit empty. So null means a reference is created, but value is not supplied into it. Value is not supplied into it. Right? Huh? What you are talking, Mr. Ankit Gupta? First, what you see in real time. Don't you see that in real time they can show that they show that you cancelled the task? Have you never seen that? They show a message that you cancelled. Think large. Don't think very short, right? Because a developer cannot be a developer. He thinks only the point. He should think all the consequences. Don't be short and immediate with a conclusion. Don't put your knowledge globally. Globally, people will not accept that. Okay. First, know about it. Think about it in all consequences. Then write. That is the first quality of developer. Not just send a message without knowing the consequences. Okay. So now here the point is there are so many consequences will be there. Here the key concept is null is defined. Null is defined when there is no value supplied into it dynamically. How you are verifying that? We are verifying that by using the null keyword. You see now, I have those all consequences working now. I click OK without entering name. Then it submits empty. For that, I written a logic that name cannot be empty. You can see now, I click OK without name. Then it says name cannot be empty. That means it is working fine. Now, here, when I click on, again, I will refresh. I click on cancel with name or without name. You entered name, but doesn't matter. You click cancelled means the prompt is cancelled. Prompt is cancelled means value is not supplied into username. If value is not supplied into username, then it will pick up null. And due to that, when I say cancel, it says you cancelled. So as our Ankit Gupta said, it will not do anything. If it not do anything, that means you are not telling anything to the user. Now user will be thinking, what is happening? That is very precise thinking, precise concept. That means you haven't shown any message to user. Simply it stopped. That's nonsense. You cannot write a program like that. That means it should show every status. Every status. You cancel, then say cancel. If you do nothing on cancel, then user is confused. Is it cancelled or not? Do I need to wait or it is doing the work in the background? So that's the reason. So whether you are programming anywhere, you have to handle this in a correct way. All the consequences need to be handled. Suppose I entered the name and I clicked OK. Now it shows that John, the value is collected. So we need to write for every consequence. Here what you understood, the main concept, what is difference between undefined and null. So tell me what you understood, the difference between undefined and null. Undefined means undefined is what is undefined? Undefined means the value is not defined. Undefined means the value is not defined. During what time? The value is not defined during the compile time. And what is null? Null means the value is not defined during the runtime. That is the compile time and runtime, how the values are configured. So that is important point you need to know. Technically, that is what we call as null types. We call as null type. Generally, null type is verified. Null type is verified by using the keyword null. So better we have to deal with this. Better we have to deal with this. in our examples later, so many times we will see that. So it looks good when you are expecting the values dynamically. That's the reason I have shown you with integration of JavaScript. Means with integration of HTML, how to convert this into HTML and do. Don't try to run this directly in console because it is using prompt, it is using document. These are to be used only in browser. So that's the reason we integrated the JavaScript into browser. You know already, TypeScript cannot be integrated into browser. We have to transcompile. The final JavaScript need to be kept here, right? So this is an example. This is an example for defining null. This is an example for defining null. So what we have done is, so create a new file. Create a new file. We need to configure a new file, right? And already we learned how to integrate. This is not a new session. Already we learned how to integrate. I'm giving the notes, once follow that. So create a new file. So we defined the file as strdemo.ts. In that we added this code. After that, transcompile. We have to transcompile tsc strdemo.ts. Then add a new HTML file, some home.html. And in that home.html, you have to link script source is equal to strdemo.js. That is enough. So already we learned how to integrate into JavaScript, means how to integrate into HTML and use a complete approach I showed you in the beginning. But these are enough. These are the steps we need to follow. You need to follow to test this. So we written in TypeScript, transcompile to JavaScript and integrate that into JavaScript. Don't try to run this directly in console. You will have problems. Suppose I say node strdemo.js, it will show errors because it says that prompt not defined, because prompt doesn't belong to console, right? Here it belongs to browser. So then you cannot use them here. You have to better do that in the console only, in the HTML file only. So this is a null type, how we can define a null type, right? So these are all under the category of primitive types, primitive data types. These are all under the category of primitive data types. We have a number, string, boolean, undefined, and null types. And after understanding the primitive types, we have another important. We need to understand about non-primitive types. What is difference between primitive and non-primitive types? In the beginning, I told you. One more point I will tell you. Primitive types, actually, technically primitive types are immutable types. Immutable. Primitive types are immutable. So they are immutable. That means actually immutable are the objects whose state whose state cannot be modified, whose state cannot be modified after it is created. So that means immutable are the objects. So immutables are the objects whose state cannot be modified after they are created. That means you can simply say that immutable are objects whose state cannot be changed once the object is created. cannot be modified once the object is created. So technically, the definition is that. That means correct to tell it in a simple way. So how we can define immutable are objects, immutables are objects, technically immutable are objects whose state cannot be changed once the object is created. And string, number, boolean, null, undefined, these are all immutable types. So are immutable. What is immutable? I will tell you. That is the reason I told you. So they have a fixed range for values. They have a fixed range for values. I will show you what is immutable and what is mutable. That is basic thing we need to understand here. Let's see what is immutable and mutable. The point here. Actually, suppose we have x. So it is a number. For this, the memory is allocated. For x, the memory is allocated. So the memory is suppose 32-bit size memory is allocated. So, and in that memory, the size for number is 32767, like that, starting minus 326767 minus 32768. That is the range, the memory allocated for this. In this you stored a number. Once it is created, memory is allocated and it is created. Now you cannot change its state. Suppose I defined x is equal to, suppose I defined 20. I defined 20. Suppose the size allocated for this is suppose 1 byte or 5 bytes or 10 bytes. Space is allocated for this. Suppose 5 bytes. Example, just roughly I'm giving 5 bytes space is allocated. And 10 value is enough. Suppose I am storing a small value like suppose 4. Now what happens is, actually initially it is stored with 10. Now you assigned 4, then what will happen is it will point towards the same memory again. When it points towards the same memory again, then in that memory the 10 will be gone and it will be stored with 4. That means every object that you declared will actually point towards the same memory. And important is, it allocated 5 bytes. For lengthy value, 5 bytes. For shorter value, 5 bytes. For shorter value of 5 bytes, and this shorter value is occupying only 1 byte, then rest of the 4 bytes will be wasted in memory. And very important is, they are wasted in the memory. And important is, of course, when they are wasted in the memory, actually what happens is, this memory, whatever is not used, the memory immediately after it finished using it, that means it came out and finished using it, the memory allocated for it will be disposed. That means it will be disposed. The memory is disposed. So the primitive types have this behavior. That means the memory cannot change, but the memory can be disposed immediately once it is finished using it. These are called primitive types. Primitive types point towards the same memory. Hence, any latest value you render into it, it will replace the existing. Hence, the memory once allocated, it cannot change. All are pointing towards the same memory. But once the memory finished using, then it will dispose it. That means it will clean up the memory allocated for it. It will clean up the memory. That is what actually primitive types. Number have that behavior, string have that behavior, and boolean, null, undefined, they all have this behavior. That is why we call them as immutable. They are immutable. So, but important, non-primitive types, they are mutable. Non-primitive types are mutable. Actually, mutable is a type of variable that can be changed, is a type of variable that can be changed. That means a mutable object is an object whose state can be modified after it is created. So after created, it can be modified. And very important is without disturbing the existing state, it can point to a new memory. Without disturbing the existing state, it can point to a new memory to handle a different value. I will tell you that to handle a different value without disturbing the existing state. That means it can change the memory as per requirement. That means hence no fixed range for values. So value range varies according to memory available. That's what actually non-primitive types. I will tell you what is non-primitive type. Actually, non-primitive types are mutable. That means whose state can be changed. For example, this time, so the above one you can see that is mutable. Suppose I have x, and for example, this is a mutable type. What are mutable types? I will show you. It is a mutable type. If it is a mutable type, that means the memory is allocated. In the memory, it is storing the value 10. That means, yes, you can say that they are dynamic. So how they are dynamic, you will see that actually. Dynamic and static are again different points. I will tell you what is dynamic and static. We will discuss that. So better not to use the words dynamic and static here, because we have a different meaning for static and dynamic again. That I will tell you in the points. Better always say mutable and immutable, not like static and dynamic, because the words static and dynamic are different. So if you use them, it will be appropriate. Why? Because what is static, what is dynamic, I will tell you once we start the OOP concept. Then you will understand clearly. Better to say mutable, immutable. Now in mutable type, so here it is storing 10. And I want some more values to handle, This mutable type can extend your memory. It can extend your memory and it can store another value. That means only one variable can point towards different memories without disturbing the existing. It can handle different values. It can point towards. So that means its size, its state can be changed according to the requirement. And usually this is in the memory of 0, this is in the memory index of 1, this is memory of 2, like that, suppose. So that means without disturbing, it can extend. Without disturbing the existing, it can extend. That is the reason one problem here is, that is okay, that's good. That is why you see we call non-primitive types. Example for non-primitive type is array. Array is an non-primitive type. We have an object. Object is also a non-primitive type. We have so many. In TypeScript, we have so many. Why it comes under non-primitive types? Array object comes under non-primitive types because their state can be changed according to the requirement. Their state can be changed according to requirement. Without disturbing the existing state, they will not they will increment, they will extend the functionality. Without disturbing the existing state, they can extend. Right? That is the ability of these non-primitive types. That means one variable can point towards several memories. So that means, yeah, yes. So something like that, right? So now the point is here, once it is not using this memory 30, it is not using its memory. One of the problem with non-primitive types, if the value is gone, the memory is not gone, the memory is still available, then what should happen is an explicit garbage collector should come. An explicit garbage collector should come. This garbage collector should explicitly remove this memory. Otherwise, that memory will be still available to handle the value. That's the reason these will occupy more space in memory than the primitive types. Because the memory will need to be automatically garbage collected in primitive types. But an explicit garbage collector should come to picture in mutable types. Then it should destroy this memory. Otherwise, it is still available. So reference types, so these are non-primitive types. Non-primitive types usually will occupy more memory. They change the state. According to the requirements. So all non-primitive types are like that. Array is like that. So generally array uses the memory index. Actually, you will learn later. So there can be an object type. Object type means, so suppose we have a product. It can have an ID. It can have a name. It can have a price. For every value, a memory is allocated. With this memory, it can access product ID, product name, product price. All are belonging to a single object, but pointing towards different memory. In this case, you are using its index number 0, 1, 2, 3. In this case, you are using its reference IDs, reference properties. That's the reason arrays and objects, all this comes under the category, and they comes under the category. Now, very much, if anyone asked you, how many values I can store in an array? How many values I can store in an array? If it is a string value, how many names I can store in a string? If I don't mention the size for array, how many values I can store in an array? Can you tell me? How many values you can store in an array? Infinite. That means you can store the complete world population names into this array. Are you sure? Are you sure? Infinite. So actually, there is a certain size. Actually, the memory allocated, actually the memory allocated for your array in the RAM, do you know in the RAM, the memory allocated for array will be up to 2 GB. Up to 2 GB. Understood? Up to 2 GB. I said if size is not defined. Understood? No? If size is not defined, maximum how much? Every technology have some restrictions. So maximum it can be. Without size defined also it will work. I will show you all those points. We will discuss about that. The point is, if I don't define the size, it's not like infinity. What is infinity? It's not like infinity. It is like maximum how much your memory allocates. That means what? Your laptop is having 1 TB of hard disk space and you can store infinite data. Na? Is it possible? Huh? You are using 8 GB RAM and you are saying that I will store infinite data. Is infinite is a correct word to tell that? Right? It is not infinite. There cannot be infinite at all. There should be some range. There should be some range, obviously. Right? So if you are using cosmic data, then you can say infinity. Understood? Huh? You are using cosmic data, then you can say infinite. You are using electronic devices. That's not cosmic data. Cosmic data means space is the limit. You can store anywhere in the space. But these are electronic devices. They will not have infinite. They will have certain range. And usually for array, so the RAM size depends on the RAM size. So depend on the RAM size, depend on the technology, Java, .NET, how much they utilize in the RAM, because RAM will not allow to utilize the entire RAM. Na? I hope you know. It will not allow to utilize entire RAM. That means there will be a certain limit for every technology to use that RAM, right? And it will use that space. That's the reason the size of these types will be varying. They will not be constant. They will be varying according to the state. They will be varying according to the state. Right, right. So this is the point about non-primitive types. Non-primitive types. So primitive and non-primitive types. And TypeScript. TypeScript, non-primitive types. Primitive types are, we have non-primitive types of TypeScript. We have an array type. We have a object type. We have an object type. And important, we have a date type. We have date type. And actually, the major are array and object. But all this considered a regular expression type. All this comes under non-primitive. All this comes under non-primitive. So that is non-primitive, right? We will see how we can manage them. How do we work with them? These are all non-primitive types. I hope everyone understood difference between mutable and immutable. Everyone clear? So everyone is clear with the difference between mutable and immutable, right? Good. So that means you know the difference between the primitive and non-primitive types. Okay. Now, what are the non-primitive types and how do we deal with the non-primitive types? We will see that. So in the non-primitive types, the first important is array. So what is array and how do we define the array? We need to understand about that. So let's see one by one how we can work with the array. Actually, technically, in computer programming, programming, arrays are used, right? Technically, arrays are used, right? Angular runs on client side, then it is obviously it will be browser memory only, na? Client side, na? It will utilize the browser memory only. That means it changes according to the browser memory. Okay. Yeah. So technically in computer programming, so arrays are used. If I say arrays are used, now you people are ready to tell that same type of values. Am I right? To store homogeneous data. Am I right? Huh? What is homogeneous data, Mr. Anil? Arrays are used for homogeneous data. Na? Same type of data. Same type of data. Similar type of data. No, actually not. Array is not for similar type of data. Arrays can handle different types of data also. Different types of data also. So generally, arrays can handle different types of data. If you say that array can handle same type of data, that can be proved wrong every time actually. Because that is your technology array. That means in Java, in .NET, or in C++, some technologies, they have a problem in allocating different types of memories in sequential order. That's the reason those technologies have restricted array to store same type of data, but array can store different types of data also. I will show you, no problem. We will see that. Generally, so actually, if you say it is same type of data, it is always wrong. It is not the definition about array. It is always wrong. I will show you here. Suppose I will create here arrays. Okay. And I will create a new file here, demo.ts. See here, I am declaring an array here. I am declaring an array here. Let some values is an array. Suppose we have an array. I will first show you simple without any types mentioning. Array. And here I am storing string. I am storing a number. I am storing a boolean. So I am storing a boolean. And I am saying console.log values dot to string. I am trying to print all those values. Now, am I storing same type of values inside the array? Is it same type values? No, they are different type values. So I will run this now. cd arrays. So here tsc demo.ts and node demo.js. You can see they are working fine. They are working fine. Understood? That means your thinking about array is related to your technology, not about array in computer programming. That means you know about array in Java, you know about array in .NET, right? You don't know about array globally. What is array? Due to that, you have a definition for array that it is same type of values, which is wrong actually. Array can handle, then you should say that in my Java, array can store same type values. In my .NET, arrays can store same type values. You should not say that array can store same type values. It will be always proved wrong. You have seen that now, practically also. Understood? That means you may say that, sir, in TypeScript, arrays can store different type values. No, in general, arrays can store different type values. In general, arrays can store different types of values also. Actually, what is the purpose of array into computer programming? Actually, arrays in array in computer programming, arrays are used to reduce overhead and reduce complexity. Arrays are used to reduce overhead and complexity. In computer programming, the main purpose of array is to reduce overhead and to reduce complexity. Right. So now the point is, what is overhead and what is complexity? So what is this actually? So reduce overhead and reduce complexity. To understand this, so I will give you a simple point. So yeah, I will give you a simple point about that. So what is overhead and what is complexity? Let's see. Actually, in early days of computer programming, we don't have arrays. I think many of you know that. So actually, in the early days, so the memory. So we used in the early days of computer programming. So we used actually memory, electronic devices. The data is stored in magnet tape, magnetic tape. You know it? Huh? The data is stored in magnetic tape. So my voice is audible to everyone. Huh? Clear? Yes, yes. So Gaurav Kumar, check from your side. There is problem your side. Okay, not here. Okay. Now, have you seen this magnet tape? Data is stored in magnet tapes. I think you might have seen in tape recorders, video cassette players earlier. Have you seen them? Right? Majority of you know that. Actually, so if you know about that, the tape will be like this. Suppose a tape will be like this, and the tape will be in this way, and usually there will be a head. There will be a head, and this head is responsible for reading and writing data into the tape. When you push a button, the head will come, and tape will move in order. In one direction, tape will move. One direction, tape will move. That means the data is being handled. That means read and write is happening sequentially. The read and write are happening sequentially. You know, if I have to listen the previous song, I need to reverse and listen. Do you know this? Huh? You know that point? Na? I have to reverse and listen. Understood? Okay. That means the point is, yes, we need to reverse and listen this, reverse and view that, reverse and view that. That is the point. Now, at that time, here, everything is fine. At that time, everything is fine. The problem here is, I don't know who these people, Asma and other people. My voice is clear from my side. Your side, you have a problem. Once check, you people. So it's not having problem to everyone. You check from your side. From my side, it's clear. Okay, right. So now here the point is, so yeah, now see here. Up to this point, we don't have, because our computers also use the same type of memory. So we don't have a problem. The problem started when we started using disk. That means CD, floppy, hard disk. Actually, you should know how data is stored in floppy, CD, hard disk. floppy CD and hard disk. How actually data is stored in floppy CD and hard disk? I will show you. Actually, how data is stored in floppy CD and hard disk. Actually, this is the hard disk. This is hard disk, internal part. That means internally hard disk looks like this. This is hard disk actually. This is hard disk. If you haven't seen hard disk internally, it looks like this. This is internal hard disk. Floppy CD and hard disk work in a similar way. Actually, you've seen here. So here, so this is actually, so that is the read write head. Read write head. That is the read write head actually. That is the read write head. And that read write head is fixed. Head is fixed. Do you know the disk will rotate round? The disk will rotate in this direction. The disk will rotate in this direction. And this read write head will move in this direction like a wiper, left, right. And you know that, many of you know that in a disk, data is stored in, data is arranged in tracks and sectors. Am I right? Data is stored in tracks and sectors. Am I right? Data is stored in tracks and sectors. You people are aware of that. You know this, na? Data is stored in tracks and sectors. Yeah. And what you need to know is in the tracks and sectors, how data is arranged. In tracks and sectors, how data is arranged. Actually, inside these sectors, how data is stored, how it will perform read write. You can see this is the head actually. This is the head. And actually this head is responsible for, that means this head is responsible for, actually that is the head. This head is responsible for reading the data in this way. That means it will move left to right. That means first value will be stored here, A. First value will be stored here. So first value will be stored here, A. After that, second value will be stored, B. After that, third value will be C. And here it stopped. That means it is not storing anything. Okay. Then disk will rotate. After disk is rotated, next value it is storing D, E, F, G. Now it came back. It is storing here 1, 2, 3, 4. That means in this way it is storing the data actually. Now what happened is, so this area is left empty. After C, this area is left empty. And this head, what it will do is, next time when it comes here, the head next time when it comes to this location, it will not continue because already data is there. Due to that, what happens is this area is left empty every time. That means there is space in your disk, but you are unable to utilize it. This problem is called overhead. Understood? Everyone understood the point? What is overhead? What is overhead? I hope everyone got that. Yes. Now arrays are designed to store values in sequential order. Do you know, actually in early days, even today also, even now also, so if you, there is space, but you are unable to utilize it. You know, in Windows operating system or in your mobiles, Windows operating system and in your mobiles, you have a disk optimization. Have you seen that? There is an option called disk defragmentation. Have you seen that? Yes. So in Windows, we have a disk defragmentation. Disk defragmentation. You see, there is a defragmentation. Yes. This disk defragmentation, do you know what happens? If I Start disk defragmentation. Actually, the disk defragmentation is happening every weekly once it is happening, because it is automatically defined. But you can manually do that. When you manually do you know what will happen? All used sectors will be pushed one side, unused sectors are pushed another side, so that data can be stored again. Understood the point? That is what actually memory is available, but we are unable to use the memory. This problem is called overhead. Now, what is the specialty of array in computer programming? Arrays are designed to store values in sequential order. Am I right? Arrays are designed to store values in sequential order. Arrays are designed to store values in sequential order. Then what is the main purpose of array? Then what is the main purpose of array? What is the main purpose of array? Tell me. If values can be stored in sequential order, then obviously it will reduce the overhead. Am I right? If values are stored in a sequential order, then it will reduce overhead problem, right? That means programming to reduce overhead. Understood? Not to store values for one aim. That is not the primary aim. That is not the primary aim. Not to store homogeneous aim of array is to for memories, managing the memory well for our application. Because if application starts using random memory, then overhead issues will come. So I don't know from how many years you are using Windows operating system or any operating system or device, computers. In early days, when we use operating system, we need to optimize our disks regularly. We need to defragment it regularly. But now the defragmentation is happening automatically internally. Due to that, we don't need to manually do that. If you manually do that or run it regularly, then your space will be better improved in the memory, and unnecessary contents will be removed, and your disk performance will be better. Actually, it is done internally. So the main purpose of array is to reduce overhead and to reduce complexity. So arrays will reduce overhead by storing values in sequential order. Arrays will reduce complexity by storing multiple values under one name. Understood? But the primary aim is reducing overhead. So arrays reduce overhead and arrays reduce complexity. One more point important about array is actually arrays can handle different types of values. Arrays can handle different types of values. But some technologies have problem in allocating a sequential memory with different types. They have some technical issues in their technologies. That's the reason some technologies have restricted array to store same type values. Understood? Some technologies have restricted array to store same type of values. Due to that, when you are learning the technology, the trainer will tell you that arrays are used to store same type values. But actually, he should say that in Java, arrays are used to store same type values. He should not say that arrays simply, because arrays means you are talking about globally across all technologies. So your technology problem you are giving as a definition for array. That is not right, because several technologies arrays can handle different types values. You cannot give a global definition for that. That's the reason globally Arrays can store different type values. I showed you here clearly that they are storing different type values. Another point is array size can be changed dynamically. Array size can be changed dynamically. Now, in many technologies, I think in your Java technology also, array size cannot be changed dynamically. No? Array size cannot be changed dynamically. If its size cannot be changed dynamically, now tell me one point, how you keep in a primitive, non-primitive type? Understood my question? Right? If array is can unable to change the size dynamically, then how you will keep it in a non-primitive type? It should not be in non-primitive type, no? Right? Because your Java or your .NET cannot handle array in the way it has been designed. That's the reason they have alternative mechanisms, like collections. You know that? You know that point? Right. That means they have an alternative mechanism like collection. But actually, so we don't need collection because array can handle everything. You see here, if anyone says array size cannot be changed dynamically, see here, I am writing here, suppose values is equal to new array, its size is 2. Into that values, I am storing 0 is equal to 10. Values of 1 is equal to 20. Values of 2 is equal to 30. Values of 3 is equal to 40. Tell me, in your technology, this is valid for array? It is valid for array? Is it valid for array? It is not valid for array because array size cannot be changed dynamically, right? But now I run this program and compile this. It is not showing any problem. It is printing all of them. Have you seen that? Understood? Now what do you say? You will dynamically. Array size can be changed dynamically, but your technology is not supporting it because it has its issues. So your technology have a problem in allocating memory dynamically for array and allocating different types of values, different types of memories in an order. That's the reason they have problem. That's the reason they have problem, right? But that should not be definition for array. Actually, in several technologies, they don't need collections because array have the behavior of stack, array have the behavior of queue, array have the behavior of dictionary type collections. One array can handle everything, right? One array can handle everything. One array can handle everything. That is the key concept of array, right? One array can handle everything. But technologies, due to the restriction, they have a limitation for arrays, right? That is the key concept of working with arrays. So the main purpose of array and very important is TypeScript array. So that means array can have the behavior of stack, it can have the behavior of queue, it can have the behavior of a dictionary type collection. So we don't need any another type of collection here because TypeScript can handle array for both situations. Do you know specialty of TypeScript? TypeScript can restrict array to same type. TypeScript can restrict array to same type and it can allow different type also. That is the specialty of TypeScript. That means it can work for both. It can work for both. For example, in TypeScript, in TypeScript. Suppose here I am adding some string. I am adding some string. It is valid. It will take that string now because it is allowing any type of value. It is allowing any type of value. So I am adding a string. It will take that string also. But I can restrict it. I can restrict it to a number type array. Then it will not accept this one. Understood? That means TypeScript array has the behavior of your Java array or universal array. Understood? That means it have both behaviors. You can restrict array to similar type. You can use array to handle different types. These are all the points about the arrays you need to understand, right? So some more points are there: how to declare array, configure array, initialize array, and all. All those points we will discuss in our next session. Tomorrow we will continue with this. Okay. So tomorrow we will discuss about all other points about array and go into this. Okay. Tomorrow we'll continue.